Hey y'all, welcome to my channel with Life with Miss H. I'm Sarah and today is Math Monday, so we get to learn something new with our math concepts today. We are talking all things ratios and rates. We're going to compare, we're going to form them, we're going to find equivalent ratios. Let's get started. And remember, for Math Monday, I do make one mistake for my students to identify for bonus points. If you're a teacher, you can use it in your class. That's awesome. There are worksheets on Teachers Pay Teachers to get these worksheets to follow along with, and it's under my store on Life with Miss H. So you are more than welcome to use those. This is also for those parents that want to help their students that don't quite understand this themselves, so they can watch it and you all can help your kids get better grades in math. So we are talking about ratios and rates today. So ratios versus rates both compare quantities. An example is what is the ratio of cats to dogs if they let you know a specific amount of cats, a specific amount of dogs. Sports is a huge place that you will see ratios. You will hear them say 3 and 0, wins to loss ratio. Rates compare two quantities with different units. They can be, so that's the difference. Both of them are comparing, but rates compare with different units. So an example is miles to hours, prices to ounces. Those are two examples that you see every day, and you just don't realize that they're rates or ratios. There are three ways to write a ratio, so you can write them in word form. So if you are comparing 3 to 5, you can write it as 3 to 5. You can use a colon, which is 3 colon 5, and you can also use a fraction bar. Even though ratios and rates are not fractions, because they are comparing things, you can still use a fraction bar, and that's what you will see most of the time when you're working with proportions, finding missing quantities, as you'll see in this video today. Okay, setting up ratios. The big thing is to look at the wording, how they have it set up in the question. You need to look at specifics. So in this case, in this example, you have 4 gumballs and 12 chocolates. Write a ratio of, and here is the big important thing, they're wanting chocolates to gumballs. So even though in the information they put gumballs first and then they put chocolates second, they're wanting the ratio of chocolates to gumballs. So the big thing is you have to put that chocolate number first and then the gumball second. Also, check to see if it can be simplified. So that's where I like the fraction form better. And since both of these are divisible by 4, you can divide the top and the bottom number. That's the big important thing. Whatever you do to the top, whatever you do to the bottom, you have to use the same number, the same operation. So in this case, it would be 3 over 1, or 3 to 1. So in fraction world, we would simplify that to a whole number because 3 over 1 would be 3. But we are comparing two quantities. So without that bottom number as 1, without that denominator of 1, we wouldn't know what we would be comparing, what the ratio of chocolates to gumballs would be. So you have to keep that 3 to 1 ratio. And just for fun, let's go ahead and write it in the 3 different forms. So it would be 3 to 1 and 3 colon 1. Okay, so here we have a table. When you're working with ratios and rates, they love tables. And so let's look at what they're wanting. Write the ratio of blue to orange shirts in 3 different ways. We are looking at the blue shirt and we are looking at the orange shirts in this question. Looking at this, I do have 5 to 9. Because we want the blue shirts first. and the blue shirts, we have 5 blue shirts. So then we can have 5:9 and 5/9. What is the ratio of pink shirts to total shirts in 3 different ways? So here we need to do something extra. We need to add these 3 quantities. We need to add the 5, the 2, and the 9 to be able to find our total shirts. 5 plus 2 is 7, 7 plus 9 is 16. We put the total of pink shirts first, and then our total second, and then we can write it in colon form and fraction form. But before we move on, you need to check and see if they can simplify. So 5 to 9 can't simplify. 5 is a prime number, so I know that we can't do anything to that one. So now looking at 2 and 16, they do have something in common. They are both divisible by 2. So I can divide by 2 on both top and bottom in the numerator and denominator. So it would be 1 to 8. And I need to write it in those other forms. So 1 to 8 and then 1:8. You want those simplified forms. Now we're going to look at equivalent ratios. So equivalent ratios show the same relationship between 2 quantities, but expressed with different numbers. To find equivalent ratios, you can multiply or divide by whatever number you want to, unless they specify in the question. So in that case, they will be saying they doubled the batch of cookies. They want to know what 4 times of it times this recipe would make. That's when they would specify the question. As long as you multiply or divide the first and second quantity in your ratio by the same number, you have to, whatever you do to the top, you have to do to the bottom. My kids know that. I've said that 5 times in the class. That is super important. To check to see if 2 ratios or rates are equivalent, you can set up the 2 ratios you are comparing in fraction form. That's the easiest way to compare, is using those fraction forms. So you can cross multiply, and what I call it with my students is the double bat method. And so if they see 2 ratios and they say, do they want them to be equivalent? They're like, oh, use the double bat method. And I'll show you in this video what that means. If your 2 products are equivalent, then your ratios are equivalent. Okay, so let's look at this example. So we're making the turkey trot trail mix, since, you'll be seeing this video in November, and November is Thanksgiving. We're going to find 3 equivalent ratios of chocolate candies to total trail mix. We are going to have to do that extra step of finding how much total we have here. We have 1 plus 3 plus 2 plus 4. So 1 plus 3 is 4. 4 plus 2 is 6, and 6 plus 4 is 10. So our total trail mix, once we make this recipe, would have 10 cups. Now our chocolate candies, we have 4 cups of chocolate candies. And since we're finding it wants 3 equivalent ratios, we're going to use that fraction form. What I tell my students, if they can simplify, simplify it first. And there's your first equivalent ratio. Since we divide the top and the bottom by 2, we're dividing by the same number. So 4 divided by 2 is 2, and 10 divided by 2 is 5. Then I also say, if they're wanting equivalent ratios and they don't tell you what number to use, make it easy on yourself. Just multiply by 2, 5, and if it can't simplify, multiply it by 10. 2, 5, and 10. 4 times 2 is 8. 10 times 2 is 20. Then I have 4 times 5 is 20. 10 times 5 is 50. So here we have our 3 equivalent ratios. All of these ratios are related to that 4 to 10. We have the turkey trot trail mix again. Miss H decided to make a larger batch of the trail mix and used 9 cups of candy corn and 5 cups of pretzels. Did she use the correct ratio of pretzels to candy corn? What I like to tell my students, set those units up first so that you know that you're putting the same numbers in the correct places. And here it tells you they want the ratio of pretzels to candy corn. You know how you want to set it up. And I tell them, when you're setting up your units, you don't have to write the whole word. You can just write P for pretzels and C for candy corn. My first ratio, I know in my recipe, I have to use 2 cups of pretzels and 3 cups of candy corn. Well, Miss H is using 9 cups of candy corn. Since we have candy corn, we're making another ratio with this recipe. Since we have candy corn in the bottom of our ratio, we need to use her candy corn in the bottom of the ratio, keeping those units common. Then we have 5 cups of pretzels, so since we have pretzels in the top of our ratio, we have to put those 5 cups. Now, we're wanting to know if she used the correct ratio. When you see that, all they're wanting to know is, are these 2 ratios equivalent? Let's do that. Since we don't have a blank spot here, we don't have any missing information, I know this is just the double bat method. Now here's the double bat. We always multiply our bats and they are crossways. So 2 times 9 is 18. 3 times 5 is 15. So we look at these 2 products. Do they equal each other? Are they the same number? So since 15 does not equal 18, they are not equivalent. This is our work. This is our thinking. This is how we find it out. We need to answer this question. Did she use the correct ratio of pretzels to candy corn? And we can say, no, she did not. Now we're going to look at rates. So rates will compare 2 quantities with different units. Some common ones you see in every day is miles to hours and price to ounces. An important rate is a unit rate, and that is when you find how much of the first unit compares with 1 of the second unit. For example, up here, how many miles can you drive in 1 hour? Or how many ounces can you buy for $1? Or how much is 1 ounce of something? All right, and here's the thing. When you see unit rates, it always has 1 in the bottom of the rate. And to get that, you divide by the bottom quantity of your rate. Whatever number is in the bottom, you have to divide by that number. And what you do to the bottom, you do to the top. And just like I was saying, miles per hour. If you see that per hour, that's a single 1 hour. So you should automatically think of unit rate. Some tips for rates. If the question says something per a unit rate, such as hours, minutes, class, sweater, they are wanting the unit rate, just as I said on that previous sheet. Another thing that I tell my students, time most likely always goes on the bottom of your rate. Just like miles per hour, money most likely always goes on the top of the ratio. So it's how much per 1 ounce, how much per 1 sweater, how much is 1 apple. Unless you are finding how many ounces or objects you can buy for $1 or 1 cent. So it's how many apples can you buy for $1? How many pencils can you buy for $1? When comparing 2 rates, find the unit rates to answer your question. If you find that unit rate, you can find what's the better buy, which one's cheaper, which one you would have to pay more for. So Miss H and her family are traveling to Disney World, which is our favorite place to go. They traveled 756 miles in 12 hours. At what rate was she driving per hour? We know that our units are miles and hours. I always tell my students, set up those units first so you can keep your numbers straight. Here I'm going to have a ratio, and they give me 756 and 12. Since they're wanting to know what the rate was she was driving per hour, I know I need 1 in the bottom, because it's how much is she driving, how far can she go in 1 hour. Now, I know I want 1 here, so I have to divide by 12. And what I do to the bottom, I do to the top. So then I can go to a calculator, or I can come off to the side and divide 756 by 12. Once I do that math, I will find out that it is 63. Since we have done our work, we still have to pull out our answer and answer our word problem, which is, at what rate was she driving per hour? So she was driving 63 miles, and we could even do per 1 hour. Let's look at another example. Miss H went to the grocery store and they were having a sale on strawberries. You could buy 5 cases for $18. How much would you pay per case? In this case, we have money and cases. So we're going to set our units up first, which is money, and I'll just put a C for cases. They tell us that it's $18 for 5 cases. And since we have per case, that means 1 case. So to get 1 on the bottom, I do have to divide by 5. And 18 divided by 5 is 3.6. And 5 divided by 5 is 1. And how much would she pay per case? And here is our answer. This is our last example. If store A sells 13 pounds of apples for $36 and store B sells 8 pounds for $26, which store has the better buy? So now we're wanting to compare these. One of the best ways to do this is just to find the unit rate. How much are you going to pay for 1 pound of those apples? Since our units are pounds and dollars, let's go ahead and put money on the top and pounds on the bottom. We're going to have, let's work with store A first. So we have $36 and 13 pounds. I want the unit rate. So to get that 1 on the bottom, I'm going to have to divide by 13. What I do to the bottom, I do to the top. And then we can go to a calculator, or we can come off to the side and we can divide 36 by 13. And we would get 2 769 thousandths. But since we are working with money, we like to round to 2 decimal places. We need to round to that hundredths place, because when you go to the grocery store, it only pops up 2 decimal places. We only have cents. We would round that to $2.77 per 1 pound. Let's work with store B. We got money over pounds. Now store B, it tells us that we can get 8 pounds for $26. So I'm going to put 26 on top, 8 on the bottom. I'm going to need to get the unit rate. So I'm going to divide by 8 on the bottom. What I do to the bottom, I do to the top. And then I can work out, I can find the quotient of 26 divided by 8. I can find the quotient of 26 divided by 8. And I can get $3.25. So comparing these prices, I always tell my students, would you rather pay $3.25 for 1 pound? Sorry guys. For 1 pound, or $2.77? I don't know about you all, but I would rather pay this. I need to come up here and I need to say store A has the better price. I hope that you enjoyed this video. I hope you learned something. You gained a better understanding of something, of the ratios and the rates, the unit rates and the equivalent ratios. So I hope that you enjoyed this. If you did, give it a thumbs up. If it helped you, give it a thumbs up. Also subscribe and share this with whoever is struggling with ratios and rates. I hope to see you all again.